Well, all right, now we get to use a little bit of our skills as far as angle pairs, linear pair, vertical angles, corresponding angles, alternate interior angles, consecutive interior angles, alternate exterior angles. These are all formed when we have a transversal cutting through two parallel lines. This doesn't apply if the lines are not parallel. Um, and we get to mix a little bit of algebra with this too. This is more fun for me. I like this better. All right, so let's see. Here we go. Got a diagram here, and I can see that I've got two parallel lines. I can tell by these little parallel line markings right there that J and K are parallel, that L is the transversal intersecting both of these parallel lines. Then it says find the measure of angle 2 if, or excuse me, find x. Find x if the measure of angle 2 equals 4x plus 7 and the measure of angle 7 equals 5x minus 13. So the first thing I need to do is I need to establish that if I can find and determine an angle relationship, an angle pair between angle 2 and angle 7. All right, so 2's right here, 7's right here, and J and K are parallel, L's the transversal, and in looking at this, I can see that angle 2 and angle 7, they got to be congruent because of the angle exterior, alternate exterior angles theorem. They are alternate exterior angles. They're not in the interior between the two parallel lines. They're on the outside of that, and they are alternate exterior angles. And so then the measure of angle 2 is going to equal the measure of angle 7. And why would that be? That'd be the definition of congruent angles. The definition of congruent angles. And then we can substitute in, using substitution, we can say that the measure of angle 2 then is 4x plus 7, and that's going to equal the measure of angle 7, which is 5x minus 13. Now we did substitution. How do you like the fact we're putting a little proof business in here? Okay, let's see. Why don't we subtract 5x from both sides, and well, let's go the other way and we'll keep our x's positive. Let's subtract 4x from both sides and add 13 to both sides. So we're actually using a little bit of the addition and subtraction property all in one step. So let's see, if we add 13 to both sides, that's going to be 13 plus 7 is 20. If I subtract 4x from both sides, well, then I'm just left with x equals 20. And shazam, x is 20. All right. Let's go do another one. All right, this time it says find y if the measure of angle 5 is equal to 68 and the measure of angle 3 is equal to 3y minus 2. So again, I'm looking to see what is the relationship that I can ascribe to the measure of angle 5 and the measure of angle 3. Again, I've got two parallel lines. J and K are parallel to each other. L is the transversal. And in looking at 3 and 5, I'm going to say that those are consecutive interior. They're in the interior here between the parallel lines. And they are consecutive interior angles. Now, if they are consecutive interior angles, they are supplementary to each other. So the measure of angle 5 plus the measure of angle 3 is going to equal 180 degrees based on the supplement theorem, or the definition of supplementary. Now let's do a little substitution. So I'm going to substitute 68 for the measure of angle 5, and for the measure of angle 3, we're going to say 3y minus 2. That's all going to still be equal to 180. And we're going to combine like terms, and so now I've got 66 plus 3y equals 180. And let's see, I'm going to use my subtraction property. And subtract 66 from both sides. And that's going to give me 3y equals, let's see, 180 minus 66, 0, 4. Bar the 1, 7 from 1 is 1. So 3y is now equal to 114. And then lastly, we're going to use our division property. And let's see, 3 will go into 11 3 times. Got a remainder of 2, so 3 go into 24 now, 8 times, and so y must equal 38 for these consecutive interior angles. Oh boy, I can't wait. This is so much fun. I'm sitting here looking at some homework problems for examples 1 and 2. Numbers 11 through 19. Now those really do look like fun. Talk about trying to confuse you. Okay. All right. You're going to have fun with those.